Getting to space has historically relied on a system that works a lot like a commercial freight train. You pack a heavy-lift rocket with as much cargo as possible, lock in a rigid schedule, and blast it toward a single destination. This rideshare model creates a massive logistical headache. The rocket unloads dozens of individual satellites along one single crowded track. But the booming small satellite industry needs their hardware placed at very specific, divergent inclinations to actually do their jobs. That mismatch creates a serious bottleneck. To clear it, the market needs a new class of agile, on-demand delivery vehicles. If traditional rockets are the trains of low Earth orbit, the industry desperately needs an Uber. That exact logistical gap is what a Hyderabad-based space startup called Skyroot'S is attempting to fill with their new launch vehicle, the Vikram-1. Historically, India's orbital launches have been entirely government operations. Vikram-1 is the country's first orbital-class rocket designed and developed completely in the private sector. Building an independent launch system from the ground up required a massive mobilization of resources. It took 3,000 days of engineering, the combined efforts of 1,000 personnel, and components from 400 different suppliers. Establishing a foothold in the global launch market requires a scalable, repeatable commercial supply chain. To function as a reliable orbital taxi, the vehicle itself has to be engineered for efficiency. The result is a 7-story, multi-stage rocket built to keep costs down and launch frequencies high. The foundation of that efficiency is the rocket's hull. Instead of traditional metals, Vikram-1 features an all-carbon composite structure. This drastically minimizes the vehicle's own weight, freeing up mass for the actual payloads. Beneath that shell, the propulsion system relies on high-thrust solid boosters, developed entirely in-house by Skyroot, to control their own manufacturing timeline. And rather than machining complex, multi-part engine components, they are printing them layer by layer. 3D printing their engines reduces individual parts that could fail and significantly accelerates the production cycle. Lightweight carbon composites and rapid manufacturing serve a precise function. They are the physical requirements to turn a single rocket into a mass-produced, on-demand fleet. That fleet takes its first major step at the Satish Dhawan Space Center in Andhra Pradesh, where the countdown for Vikram-1's maiden test flight has officially begun. The target for this delivery run is exact, dropping a payload of up to 350 kilograms into a 450-kilometer low Earth orbit, angled at a precise 60-degree inclination. To prove they can handle the highly bespoke needs of future clients, Skyroot loaded the vehicle with a highly unusual manifest. Alongside traditional tech, Vikram-1 is hauling actual luxury goods, including diamond jewelry and an 18-karat gold miniature rocket. That golden rocket serves as a tribute to Indian science legends, featuring intricate microsculptures, starting with the Nobel-winning physicist C.V. Raman. The golden payload also honors Vikram Sarabhai, the primary architect of the Indian space program, and completing the tribute is aerospace engineer and former president APJ Abdul Kalam. Packed in right alongside the gold and diamonds, the cargo hold includes a robotic arm experiment from Komasur Space, Skyroot's own satellite, and 2 demonstration units from Germany. This combination of high-value luxury goods and delicate experimental hardware acts as a live demonstration of the vehicle's capacity to handle sensitive passenger needs. While the cargo is interesting, this mission is strictly a technology demonstration flight. The gold and the robotics are entirely secondary to the primary objective, acquiring flight data. Engineers will track telemetry and onboard systems under the intense physical stress of an actual launch. That real-world data is then fed back into the manufacturing pipeline to refine and improve future iterations of the rocket. There is a tremendous amount of capital riding on that data. Skyroot recently closed a $60 million funding round backed by heavy-hitting international investors like Singapore's GIC. A successful flight validates the hardware, and that hardware validates the company's $1.1 billion valuation, officially cementing Skyroot as India's very first space tech unicorn. If Vikram-1 reaches orbit, it breaks a decades-long government monopoly on Indian spaceflight, clearing the path for regular, privately managed commercial launches. Reliable, on-demand transport is the foundational layer for a new orbital economy. It provides the delivery infrastructure necessary to deploy massive satellite constellations and eventually support specialized manufacturing projects in low Earth orbit. Before any of that off-world economy can be built, The logistical bottleneck of getting materials there on demand has to be solved. Skyroot's overarching goal is to move past simply launching rockets, turning a flight to orbit into an everyday service as routine as catching a plane.